Hello, my name is Danays, and I'm an educator at HistoryMiami Museum. And today we're going to talk about maps. Can you believe that there was a time when people lived that they had no idea what the whole world looked like? Well, today we're going to talk about how people navigated the ocean before maps, a brief history of maps, and why creating maps was harder than you may think. For most of human history, if we wanted to move beyond our home, we needed to have, at the very least, knowledge about the land surrounding us, and be able to know where you were going, and more importantly, how to get back. I guess unlike today, really. Polynesian navigators in 1500 BCE used a variety of techniques to navigate the collection of islands that today are known as Polynesia, including Hawaii. Navigators had a deep understanding of the ocean, and by using knowledge of the Earth's unchanging ocean currents that flow east to west, the flight patterns of birds and the motion of the stars, moon, and clouds, they navigated the Pacific, the world's largest ocean. Over in the Atlantic, the indigenous people in the Caribbean archipelago were navigating the ocean, albeit a much smaller region. Take a look at this map from the book Antillean Visions. It shows the visibility in nautical miles. The areas that are shaded red or yellow means you could see neighboring islands while out at sea. So, navigators often had a view of land up ahead or a view of the land they had just left. Navigating by land had the benefit of using maps. Islamic scholar Al-Adrisi's world map of northern Africa, the Mediterranean Sea, Europe, and parts of Asia was used in the 12th century and was created with the south facing up. His maps were very accurate and were used for centuries. But as the people of the world and countries began to explore, they needed maps with larger scopes. Cartographers, also known as map makers, wanted to create bigger maps that documented more parts of the world. This map is Ptolemy's The Known World, that popularized latitude and longitude lines. These lines are there to show the curves of the Earth. Longitude lines show north to south, up and down. Latitude lines show east to west, left to right. But if you keep expanding your scope to map out the entire world, you'll run into issues in design. The problem is, how do you get a flat image of a 3D object? Let's use an orange as an example. If you cut the skin of the orange into 4 equal wedges and lay them out, you can't ever seem to be able to make them perfectly flat or fit together. No matter how hard you try to make the wedges flat, it just can't happen. In the 1500s, Gerardus Mercator created the Mercator Projection that solved this problem by stretching the top wedges of the Earth horizontally and vertically to create a flat image. This gives you what is called constant true direction, which allows people using the map to create straight lines between 2 points that can be navigated with a compass. The closer you are to the equator, the more accurate the lines are. So, how do you use these lines while trying to navigate at sea? Well, besides a map, you would need a compass. It doesn't have to be anything fancy. Pirates made compasses at sea by stroking an iron needle against a naturally magnetic mineral called a lodestone. So, once you have your compass, it's time to read your map. Latitude lines, east to west, could be figured out pretty easily. If you were located in the northern hemisphere and you knew which way was north, the date, and where the sun should be in the sky at noon, you could figure out your latitude. Along longitude lines, north to south, maps included visual cues such as landmarks, a unique coastline, like our Florida coastline for example, or man-made sites that were visible from the deck of a ship. Also on a map, you may find a compass rose that's oriented north. Here, you could see it on the left. This orientation means that this map was created with the northern hemisphere being above the equator, and it also shows the other cardinal directions, east, south, and west. The Mercator projection became very popular, and it still is. We use this projection in navigation apps like Apple and Google Maps. And while this map was incredibly useful for navigators, it wasn't very helpful for people trying to visualize and understand what the world looks like. Think about the orange. Because the world and the orange are 3D objects, to make this flat projection, the land at the poles had to be stretched and expanded. But just like the orange, what part of it is really up or down? What if instead the map was created with the southern hemisphere being above the equator, like Aladrisi's world map? Or like this Macarthur map, created by Australian Stuart Macarthur, which has the southern hemisphere facing up. How differently would our ideas about the way we visualize the world be? Does Australia really have to be the land down under? Check back for part 2, where we'll talk about how a warm water current was used to create politically motivated maps that distorted Florida and the Caribbean islands and made them look like this. Thank you for joining us on another episode of Inside the Museum. For more information, check out or go to our website at www.historymiami.org.